Welcome back, class. Go ahead and open up your books to page 487. I'm going to get the screen fixed right here. Go ahead and open up to page 487. This is lesson 4, dilations. Okay? So, go ahead and pause it if you need to. If not, let's go ahead and get started. It says, a dilation uses a scale factor to enlarge or reduce a figure. Okay? So let's look at this graphic organizer here about what is a dilation. So dilation is basically a scale factor. It will enlarge or reduce. Some people think dilations are just expanding, but it's actually enlarge or reduce. All right? So things that are like this. What are things that are like this? Well, basically an enlargement. So an enlargement would be like this. Or a reduction, any type of reduction. Or you could, like a scale drawing. Okay? Like a scale drawing of a building, like, kind of like a blueprint, maybe. Or even like a model car. Okay? Like a model car is basically, they took a car and then just like shrunk it down. All right? What are characteristics of a dilation? Well, characteristics of a dilation, basically it's an enlarging or a shrinking, but the shape overall stays the same. So characteristic is it's a different size. Okay, it's a different size, but same shape. So it's an identical shape that's just been enlarged or shrunk down, okay? Now, things that you've already learned that you can use that are going to be helpful. If you've done things with ratios, and remember ratios, like a 2-to-1 ratio, 3-to-2 ratio, that would be helpful. If you've done anything with scale factors, that's like way earlier in the year when we did stuff with like maps. They had a scale factor on a map, like, hey, 1 inch on the map equals 50 miles in real life. Or anything with graphing, which we've done a lot of recently. Those type of things will help you out, okay? So let's take a look here. At the next part here, it says photography. It says Nisi wants to insert a photo of her dog on her blog. So here's her dog. She wants to insert that on her blog, all right? The current size of the photo is 480 pixels by 640 pixels. Suppose she wants to reduce the photo to 120 pixels by 160 pixels. Compare and contrast the original photo and the reduction. Okay, one thing I'm going to do here is I'm going to simply just do a basic division problem where I'm going to take what it is currently, 480, and I'm going to divide that 480 is connected to the 120. So I'm going to take 480 and divide by 120. And what I get is an answer of 4, which tells me that the new photo is going to be like 4 times less, okay, or it's going to be 1/4. Now I'm going to do it with the other numbers here. I'm going to box those just to make sure that it stays consistent at a differential of 4. So I take the 460 and I divide by 120, and I get a 4 as well, all right? That tells me, all right, compare and contrast the original photo and the reduction. I would just say that the original is 4 times, I'd say 4 times greater, probably is the best way I'd say that. All right? And then it says, what is the scale factor from the original to the reduction? Now here's where you got to be careful. It says the scale factor from the original to the reduction. So I can't say times 4. I can't say it's 4 because from the original to the reduction, I didn't multiply by 4. It's not 4 times greater. She's not making something more, she's making it less. So it's not actually 4 times greater when we go from the original to the reduction. It's actually 1/4. Okay? So I was actually noticed I was dividing by 4, so it was actually only 1/4 as big. All right? So make sure you be very careful with the order there that it wants things. All right? Go ahead and turn the page. That's kind of a basic idea of dilation. So now let's look at like the concrete math type of stuff. All right? Here it says dilation in the coordinate plane. A dilation with a scale factor of k. Now I want you to circle K. K is often referred to as the scale factor. So you'll have like K, I have this to the side here, like K equals 1/3. That means it's a scale factor of 1/3. And I'm actually going to delete this and get this out of here. And then, let's see here. So a K could be 1/3, or that means you multiply everything by 1/3. Or a K would equal 4. That's the scale factor. That means you multiply everything by 4. Okay? So here we have a picture here. It said an enlargement or an image larger than the original. So the picture will get larger than the original if your K is greater than 1. So like here, we would know if that was a dilation. If K is 4, that's greater than 1. We know we're going to get a picture that's bigger, that's greater. It says a reduction or an image smaller than the original if the K is between 0 and 1. So like 1/3 is the same as like 0.33 repeating. So that's between 0 and 1. So we know if we had a K factor of 1/3, it would make the picture smaller. All right? Now this is key. What if the K is 1? Well, then the picture would just stay the same because we'd be multiplying everything simply by 1. All right, let's take a look at an example here. So here, basically, it kind of outlines what to do. We first look for the scale factor. It's 4, all right? So scale factor of 4, that tells me I'm going to take all of my points here, and I'm going to multiply each number by 4. And this is basically how you show your work, okay? It's just like it did here, and I'll outline more of it over here. Your A is 0, 0. So I'm going to do 4 times 0. Well, why 4? Because that's my scale factor. So 4 times 0 is 0. 4 times 0 again is 0. So my A prime is simply that 0, 0 right there. Now let's do point B. Well, B is the point 8, 0. Once again, I'm multiplying by 4. So I multiply 8 by 4, and I get 32. And then I multiply 0 by 4, and I get 0. That's going to be my B prime. Here I have a C, 3, negative 2. So I take 3 times 4, which gets me 12. Then I take negative 2 times 4, negative 2 times 4, and that gets me negative 8. So 12, negative 8 is my C prime. All right? That's basically how that works. Now let's do these, okay? And here's how you need to do these in order to show correct work. You need to write down your original points, all right? So we're going to write down our original points. So I have W, and then I'm going to write the point, negative 2, comma 4. And all me and Miss Neely really need you to do there is make an arrow, show us what you're multiplying by, okay? So the K here, if I read the problem, it says a figure has vertices of W, X, Y, and Z. Find the coordinate of the figure after a dilation of a scale factor of 2. So put times 2, make another arrow. That shows me, okay, I'm multiplying everything by 2. And so W prime is then negative 2 times 2, which is negative 4. 4 times 2, which is 8. That's my W prime. Then do the same thing for X prime. Or sorry, X in order to get X prime. So X is 1, 4. Make an arrow. Write times 2. Make another arrow. Then write X prime. And 1 times 2 is 2. 4 times 2 is 8. And there you go. Now what I want you to do underneath, or actually do it to the side right here, I want you to specifically do it over here on the left. I want you to complete Y, and I want you to complete Z. Okay? And if you have to use the line below, feel free to use the line below. But make sure you complete those on your own. Y is 3, negative 1. And then Z is negative 3, negative 1. Show me what you're multiplying by, and then get me the Y prime and Z prime. Do that on your own. Pause the video right now if you need to. All right, if you finish that, we'll check the answers for that when we check notes tomorrow. Go ahead and come to the next problem. Here's when we actually look at graphing. Okay? So basically, if you look here, don't get too confused by all the stuff that's going on there. We have 3 points, J, K, and L. It says graph the figure and the image of the figure after dilation with a scale factor of 1/2. Now, 1/2 is the same as 0.5 if you're using your calculator, okay? So here, it's going to shrink the figure. So here's our original. Notice 0.5 is less than 1, but greater than 0, so it's going to shrink the figure to right here. Now notice it didn't shrink inside of it. That's a common mistake. It didn't shrink down inside of itself. All the numbers became less, so it shrunk down, and it's kind of in a new position. So notice we took our points, 3 and 8, took 3 times 1/2. We got 3 over 2, or 1.5. Then we took 8 times 1/2, which is 4. Okay? And that's how we got our new points there. So it's doing the same thing. It's taking your original point, multiplying by the K, getting a new point, and then just graphing. So here's what I'm going to do here. Follow along. It says a figure has vertices f of -1, 1. So back 1, up 1. That's f. Okay? Then we have 1, 1 is g. Forward 1, up 1. That's g. Then we have 2, -1. So h is forward 2, 1, 2, down 1. That's h. And then we have I, which is -1, -1. So back 1, down 1. That's I. So that's our picture right there. Okay? Now from there, I need to do my work. So I need to find the scale factor. All right? The scale factor for that one is 3. So that's what I'm going to be multiplying by. Now to show correct work, you need to write your point, your original. So my original F, G, H, I. I'm going to write all my originals real fast, and I kind of do this when I do these because there is a little bit of work. So I kind of do this first. That way I have all my work lined up, ready to go. I have -1, 1 for F. Then my G is 1, 1. My H is 2, -1. My I is -1, -1. Okay? So I'm multiplying by 3. So times 3. Make sure you write times 3 for all of them. Make your new arrows. And now I'm going to have a new F prime, G prime, H prime, and I prime. All right, I'm going to have all those points brand new. So I multiply by 3. -1 times 3, -3. 1 times 3 is +3. So that means back 3, 1, 2, 3, up 3, 1, 2, 3. That right there is my new F prime. All right. Then G is 1, 1. So I multiply by 3. So that gives me 1 times 3 is 3. 1 times 3 is another 3. So that means forward 3 and up 3. 1, 2, 3. And then up 1, 2, 3. That right there is my new G prime. Okay. Make sure you're labeling. And I want you to finish the other two on your own and finish this picture on your own. Okay, so finish this picture on your own, finish those points on your own, and we'll be checking that in class tomorrow. Now for 3, example 3, it says, through a microscope, the image of grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? Write a ratio comparing the diameters of the two images. So the diameter of the dilation is 11.25. The diameter of original is 0.25. So just take those numbers, divide. So my K, when it talks about scale factor, that's your K. So here my K equals 45. Now we're going to turn the page. So basically on your own for this one, it simply says, Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? So here, to show work, I'm going to take my 7.5 and I'm going to divide by my 3. So I take my calculator, I do 7 1/2 divided by 3. and I get 2.5. Okay. Then I'm also going to check my other point. I want to make sure it matches up. So I'm going to do 12.5 divided this time by 5 to make sure it all matches up. So do 12.5 is 0.5, so you can do 0.5 if you want. 12.5 divided by 5 gets me 2.5, which is the same as 2.5. So our scale factor is 2.5 or 2.5, whichever way you want to list it. All right, if you have any questions, feel free to come back tomorrow with any questions you might have.